Hello all enthusiastic learners. Today we will see this chapter 7 axially and eccentrically loaded columns and topic is Euler's theory for long column. See first bullet point. The Swiss mathematician Leonhard Euler in 1757 derived a formula for the stability of long column. See this formula. Crippling load PC is equal to pi square EI upon L square, where this E is Young's modulus, I is least moment of inertia and L is effective length. This all we had seen in our chapter 1, but I will tell you this also. So now see this number 2 bullet point. In Euler's theory, the column is fails due to buckling only. See, in our previous lectures, we had seen that why column is fail due to buckling and for which column this buckling occurs. We all seen that we all saw that this buckling happens in a long column. So that's why this Euler's theory apply for long column. Here buckling word comes. So third bullet point is effect of compressive load is neglected. Here effect of compressive load is neglected because see due to this buckling there are other other stresses comes and these other stresses are like maximum than this compressive stresses. That's why see this bullet 4 point, the effect of direct stresses is neglected because the direct stress induced in the long column is negligible as compared to bending stresses. Due to this buckling, bending stresses are greater than that direct stresses. That's why this happens. So bullet number 5 point is this theory is not used for short column because the direct stresses is considerable in short column and hence cannot be neglected. So see this Euler's theory is apply only for long column and this column fails due to buckling only, and in this we cannot consider effect of compressive load. We are only consider that bending stresses, and this theory is applicable only for long columns. So and formula is PC is equal to pi square EI upon L square. So this is all about that Euler's theory for long column. And I told you that pi square is constant and E is like modulus of elasticity. In our chapter 1 we had seen that term modulus of elasticity, but see again we will see it. Modulus of elasticity or Young's modulus definition is the ratio of stress to the corresponding strain is a constant, and this ratio is known as modulus of elasticity or Young's modulus. And see this modulus of elasticity we derived from Hooke's law. Hooke's law is nothing but the when a material is loaded within its proportional limit, the stress produced is directly proportional to the strain. So stress is directly proportional to strain, and see like we will see it again. This is our chapter 1 concept, but need to see it. Stress is directly proportional to strain. Stress is equal to uh, constant into E, like constant into E, and stress upon strain is equal to constant, and this constant is nothing but the modulus of elasticity, the ratio of stress to the corresponding strain. And this I, moment of inertia, we had seen this also in our chapter 2, that moment of inertia we will see now. Wait a second. See definition of moment of inertia. Moment of an elementary area about any axis is given as the product of area of element and square of its distance from the axis is called as the moment of inertia, and unit is meter raised to 4 or mm raised to 4. See, I will give you link of that like moment of inertia and that like that modulus of elasticity concept in that description box, because I told you earlier also that, and the effective length also I told you that previous lecture is about effective length. that effective length is nothing but the distance between the point of contrapicture of column. Remember this formula: PC is equal to pi square EI upon LE square. Okay, thank you very much.